Okay, this problem says a fireman has a mass m. He hears the fire alarm and slides down the pole with an acceleration a, which is less than g in magnitude. Write an equation giving the vertical force he must apply to the pole. If his mass is 90 kgs and he accelerates at 5 meters per second square, what is the magnitude of his applied force? Okay, so here's the pole, and here's the fireman. He's sliding down the pole. Okay, so he's grabbing onto the pole, and there's a friction force. That force is in the upward direction, and here's his weight acting downward. Okay, and that is his acceleration. And so obviously, so there's a couple of things that you're trying to do. Okay, if you just jump off the second floor, you'll get there faster, and then you get to the fire faster. Except that if you do that millions of times, your knees get shot pretty fast. Okay. So you hold on tight, make this acceleration as small as possible so you don't hit the ground with too large a velocity. Okay. I know somebody whose husband was a skydiver and his knees are shot, even with a parachute, you know. So anyway, that's the idea. So you're balancing quickness and trying to preserve your knees as well. Okay. All right, so the problem is simple. The net force, here's Newton's second law. And Newton's second law says mg minus F equal to m times A. Write the equation given the, okay, so the vertical force you must apply is mg minus ma. Okay. Now, so from this equation you can see that, and let's make sure this makes sense. If his acceleration is g, that would cancel that. The force he's applying is 0. And that makes sense. You don't even have to hold onto the pole, just jump off and your acceleration will be g. What if the force he applies is equal to mg? If this is equal to mg, that'll equal that. Acceleration will be 0. Okay. So that would be the best strategy. You know, give yourself a velocity and hold on to it as hard as possible. You're supporting your weight. Your shoulders will get stronger, and your knees will be preserved. Yep.
This is all in the for the y component of the force, right?
No,
There's no the force in the x direction.
Right. See, I'm assuming you're smart enough to figure out all of that, and that's why I don't tell you all of that.
If the force he applies is equal to gravity, he's not going down the pole.
So the net force is 0, acceleration is 0, but that doesn't mean the velocity is 0. He can give it, you know, that is the best strategy. Yep. All right. Okay, that was part A. Now part B says if the mass is 90 kg and his acceleration is 5 meters per second square, what is the magnitude of the applied force? So okay, so you'll get a number here, and it'll tell you nothing, but okay. So here's a better number. mg, and 5 is 5 divided by 9.8 is 0.51 G's. So the force he's applying is 4 mg. So here's a better number. So he's applying a force 49% his body weight. in the upward direction. Okay. Yep.
Is that number right there in the second to last part of B?
Mm-hmm.
Is that M multiplied by G minus 0.519?
So this is G.
Which is 9.8.
Yeah.
Okay.
The reason I'm writing it like this is your body weight, and this is 49%, 0.49. So you're applying a force of half your body weight in the upward direction. Okay. That makes more sense. All right. Any questions before we end this problem? Okay.